So now we will go to the topic of variables and functions, which is this line here. So here we have a function. This function, we pass some parameters to this function. This function will use this to do something, and this function will return, in this case, two values or two kind of data that will be stored in this variable. So a variable is a memory location to store data. So it's a label to assign a value to it. So there is some space in memory in the computer, and we put there a value, for example, 48,000, and we call this space sample rate. So every time we type sample rate, the interpreter will go to this space in memory and will get there and give access to this. A function is a block of code that performs something. In this case, load here is a function, and these other two here, they are variables. So the variables is a label for a location in memory, and it can be used to hold a value. So in statically typed languages, variables have predetermined types, and a variable can only be used to hold values of the type. So if you are in a different programming language and you want to use a number that will be an integer, you need first to define, okay, I will create a variable that the type of this variable, it will be an integer. And then if you try to store something that is not an integer in this variable, you have an error. In Python, you may reuse the same variable to store values of any type. To define a new variable in Python, you simply assign a value to a label. In this case, we are not assigning a value directly, but we are calling a function. This function will return some value, in this case 2 values, and these values will be stored here in audio data. So this is a label for this array of numbers here, and this sample rate is a label to store this number here, 48,000. Now a function, so we've seen that function is a block of code that's doing something, and we can create a function that, for example, this Fibonacci example, using this structure here. So you put def, something like a define, then you have the name of this function, and here is like it takes some parameters or it takes some arguments. So here def is also a keyword that introduces a function definition. So we cannot use this def to define a label. We need to use this just to introduce a function. Then it's followed by the function name and the parenthesized list of parameters. Then inside here, we write what this function is doing. In this case, it's not returning anything, it's just printing. So it's displaying on the screen something. Note that in Python, this space here is an indented language. So this space here, it means something. If you just delete this space and everything would be here, you would have an error. So indentation is part of the Python language. So we will see more about functions a bit later. As convenience, function names should be lowercase with words separated by underscore as necessary to improve readability, and variable names follow the same convention as function names. Mixed case is only allowed in contexts where there's already a prevailing style to retain backwards compatibility. So pay attention that this is a suggestion. If you can name your variable or function any way you want, but it is a convention to use lowercase for functions and variables. So here we will take a look into this Librosa.load function. So this is a function. So it takes these arguments here, so these parameters. You don't need to pass all the parameters because some of the parameters, they have a default value. So if you don't, you need to pass the path, and if you don't set a value for any other value, it will use these parameters here. So it will already convert automatically your sampling rate to this value. This is what I find a drawback of Librosa. I would prefer always that the default will be none. That this means that it will load with the original sampling rate. It will convert our file to mono. So our file can be stereo, then we would have two channels, but by default Librosa will convert it to mono. We can set an offset, so the audio would start, for example, 1 second later and not in the beginning. We can set the duration, so it would, for example, load if the file is very long and we just want 1 second, we could set the duration to 1 second. But if we don't define anything, it will take these default values. So next we have here a description of what this function is doing. So it's very important that you document your code. So here is part of the documentation. When you have these triple quotes here, defining from here until the end here, this is a comment. So Python interpreter will not execute this part here. It is here just for us to read, and we know that this function load an audio file as a floating point time series. Our audio will automatically be resampled to the given default value. If you want to have the original sampling rate, you should use none. So this is what we discussed before, and now it will tell what are these parameters. So if you don't know what is path, and then you look here at the documentation, and there will be path. It's a string, int, path, lib path, or a file-like object. We will talk about this string in a few moments, some of them, and we will talk about them as we encounter them. And it's a path to the input file. So if you want to open a file, you need to tell this function where this file is so it can load it. Then it will have also some examples. So if you don't know how to use this function, you can look here in this help, and it will give you an example how to load a file and resample it to 11 kilohertz, how to load an OGG 4bis file, how to load 5 seconds of the file starting 15 seconds with this. And this is the documentation of the docstring of this function. So we are at Librosa.load. So in our code example, we are passing this, which is a string. So this is the path. As it is inside the current directory, we don't need to tell which directory it is, but if it would be in the sample data, for example, we could use ./sample_data/tone, and it would find this file. So after this documentation of this function, we will see the code that this function will do. So it will try to use this sf.sound file. This is the path, so this is another Python package that this Librosa is using. And then it will seek the start of the target read. Then it will load the targeted number of frames and transpose to match the Librosa form. If it fails, it will try to use a different thing. Then if its mono is true, it will convert it to mono. If sampling rate is none, then it would use the native. If it's not none, it will convert. If it's none, it will use this native sample rate, and it will return this y. It's a variable that it's used, loads a lot of things and manipulates, and will return this y value and the SR also from here. So for example, it will use the native sample rate and it will return this value. And these values can be, for example, an array, it can be an integer, it can be a string, and we'll see all these data types later on. So here it is, we have Rosa, we have .load, so it's calling this function inside of Rosa. We are passing this name of this file under quotes. We will explain later what is this quotes here. None, it is a reserved word. So here I'm listing here all the reserved words, the keywords, so none is one of them. And it will this function will return to data that will be stored in these variables. So this is an example here, the function load. And here we will, just as an example, define a function to calculate the sampling period from the sampling rate. So from the theory part, we talked about what is sampling rate and what is sampling period. So if you're not familiar with that, you can go back to the tutorial where we talk about this. And then we are defining, then this is a keyword to define a function, the name of the function. Under parentheses, we need to give the sampling rate that we want to calculate the sampling period. Then I'm writing here the documentation of this function. So there is a description what this function will do. What is the parameter? So it will be an integer. This is the sampling rate to be used. So 48,000 kilohertz, 48,000 hertz, for example, and it will return the sampling period. It will be a float number. So it will have, for example, decimal points, and it's the sampling period of the used sampling rate. And here's an example. And then this function will return. Return is another reserved word that returns a value from that is calculated here. In this case, we have the sampling rate, and we take the inverse of the sampling rate, so 1 divided by sampling rate, and we're returning this value. So when we run this function, it will calculate the sampling period of the sampling frequency here. So if we want to store, so let's call sampling period equals this. So let's run this cell. So now this calc t is a function that is already inside our interpreter. Now we are calling this function, and we are storing this value that it returns into a variable called sampling period. And now when we are using Jupyter Notebooks or Google Colab, it will already display the returned value. So we don't need to write print if it's the last thing what we put here like we did before. So it will display here. But if we do print below, and we will see what print is next. So it's not displaying this, it's displaying this, but we can store this as a sampling period. So we have a variable that is a label to the data that this function returns. And now if we put sampling period, we have this. Or we could also put print sampling period, and we would have this value here. So it's 1 divided by 48,000. If you want to know for 16,000, we just do it again, and there will be this value here.